Hey guys, Mr. T here's another video. This one's on number of paths problems. So once you've constructed a network, you're going to be asked to investigate paths through that network between nodes. All paths problems that you do are going to assume no backtracking, unless of course the question says that you can backtrack. Or if it's a directed network and you have to backtrack. So that means movements between nodes along arcs and edges always go towards the endpoint. So what I mean by that is that in most questions, unless it says otherwise, if you're going from A to B, it's going to assume that you are always moving closer to the target. So if I'm going from A to B, if I went up there, then went across there, I've got two different ways that I could go closer towards B. I could go up there, across there. That would not be moving closer towards B. So it's assumed that you're not going to go down there. You're always going to go closer. So if I went up, you're not going to go here because that's going further away from B. It's going to be assumed that you're going towards B every time. So that is what you would be assuming. You're not going to be assuming something like this went across, then went down. That's a backtrack because you went further from the goal. Obviously, now that you've backtracked, you're still going closer. Lucky that didn't turn into an inappropriate sign. Good to avoid that. So that's all good. So that would not be acceptable because you backtracked. You went further from the goal. Alright, example. Let's do a direct example here. So something that you might encounter in the questions. Let's say Jason walks from a school to home. The network below represents possible paths and nodes he can take. Draw all possible paths Jason can take from school to home without backtracking. So you're going to notice here, none of this is actually maths. You're just using logic and reason. And being sure not to be lazy about it. And following the rule, no backtracking. So here's a network. This is the school to home. The other nodes aren't drawn in because they're not important for this. All you've got is the paths. Let's assume the corners are the nodes. So it's asking you to draw all the possible paths he can take without backtracking. So if you're going from school to home, let's go with the most direct. So from there, going up, going across, and going home. That's one. Let's take another direct one, across, up, and across again. How else could he go? He could go up, across, and then without going straight across, I'll go up again because that's still closer to H, and then go across. So that's another acceptable path. Where else could we go? We could start from there. We could go across, up, and instead of going up again, we could go across and then up. So that's another path. Starting from here. So we've exhausted all of the paths that go straight up and across, I believe. Straight up, across, all the way across, straight up, across, and then up again. So we're going to have to not go straight up. We'll go straight this way and then across. Then all the way up and then across. I don't think I've done that yet. Yeah, that's correct. So obviously if I just did that, I could go up, across, again, and then up. So that's probably the longest path. Zigzag the whole way. What else is there? I've exhausted all that. So now the last little option is to go across, then up, and then across again, all the way up to H. What last one is there? I know from the textbook that there is another option. So the only other option that I haven't done is to go across, up, stop here, go across again, and then up, because that's different to here where I went up and then across. So that's an example of a possible parts, all possible parts problem. There's 8 of them here. Hopefully that helps you out, and see you in the next video.